Alrighty guys, so today we're going to get started, and the lecture notes or the lecture today is called Basic Ion Interactions. So if you guys remember from last time, an ion is basically a charged atom. Okay, so it's an atom that either has a positive or negative charge, which means that the number of protons and electrons are not equal to one another. Okay. So we're basically going to be figuring out how these ions, these charged atoms, they interact. So what do ions, these positive and negatively charged atoms, what do they do when they're next to each other? That's basically what we're going to be talking about today. But before we do, let's just review a couple things about ions, how to find them, how to find the charge, and then we'll move on to how they interact with one another. Alright, so for the warm-up, the first problem, we're going to write the ion symbol for the atom that has 13 protons and 10 electrons. Okay, so what we're going to do here is we're going to start with the protons because this tells you what element it is. Okay, so it says that we have 13 protons. So what we're going to do is we're going to go to our periodic table and we're going to look for the element that is the number 13. Okay, you're going to notice that 13 is going to be aluminum, and it's the same aluminum that your foil is made out of. Okay, but we don't need to write the name because in this problem it's just asking you for the symbol. So we're going to write the symbol, which is Al. So we're going to write Al. Alright, but we're looking for the ion symbol, which means we need to find the charge for aluminum. So what's the electronic charge? Now, if you guys remember, the way that we find charge is we do protons minus electrons. Okay, this is the formula. So if we're looking for the charge, what we need to do is we just need to plug in our protons, which is 13, minus, and our electrons, which is 10. So 13 minus 10 is going to be 3. But if you guys remember, for charge, we need to specify if it's positive or negative. Since it's there's no sign in front of it, we know that it's positive. So that means the symbol for our atom, this ion right here, is going to be Al3+. Okay, and this is going to be the symbol for this problem. Okay, so just remember when you write the charge here, we always put the number and then we put if it's positive or negative. We don't do this. We don't do Al plus 3. Okay, that's incorrect. We have to put the 3 before the positive. Alright, for this problem we're going to go the reverse. This time it's asking us how many protons and electrons this atom, Au4+. Okay, so what we're going to do is first we need to look for Au on the periodic table. So we're going to look for Au, and you should notice that Au is somewhere in the middle. Okay, and Au is gold. Okay, so we're going to be looking at how much gold 4 plus, how many protons and electrons it has. Okay, so the protons are really easy because it's just the number on the top. We've been doing this for a while now. Okay, so that means that gold, Au4 plus, has 79 protons. Okay, the electrons is the one that's a little bit trickier. But the way that we find electrons is, again, we're going to use this formula right here. Charge is equal to protons minus electrons. So charge is equal to protons minus electrons. Okay, we have the charge. It's this right here, positive 4. So we're just going to put 4 equals, and then the number of protons is 79. So we have 79 protons minus electrons. So basically we just need to solve for the electrons. Okay, so last time we talked, I said there are 2 ways to do this. You can do this multiple ways. First thing you can do is you can do it the regular math way. So let me get this out of the way real quick. Okay, we can do it the regular math way. So the regular math way is to just do algebra. So I'm going to copy down the formula. 4 equals 79 minus electrons. So we want to find electrons, so we need to isolate the E by itself. Okay, so in order to get rid of 79 here, since we're doing 79 minus E electrons, what we're going to do is we can subtract 79 from both sides. Okay, because if we subtract 79, the 79 cancels out, and on this side, we only have negative electrons. Okay, 4 minus 79, you punch that into your calculator, and you should get negative 75. And since there's a negative on both sides, you can cancel out the negative. That means that there are 75 electrons. Okay, so that's one way you can do it. The other way I think is a little bit easier is you just kind of need to think about it. Okay, 4 equals 79 minus electrons. So you just need to think about it, like 79 minus what equals 4? Okay, so 79 minus what, question mark, equals 4. Okay, and if you kind of just think about it, you count backwards from 79, you go 78, 77, 76, 75, so that's 1, 2, 3, 4. You count backwards, and you should get 75. Okay, so there's multiple ways to do it. As long as you can get a consistent answer using the system that you have, that's totally fine. But for the answer to this problem, we have 79 protons, and we have 75 electrons. Okay, so hopefully that helps you and refreshes your memory on how to find ion charges and how to write the symbols, because we're going to be referring back to that constantly. All right, let's move on. Okay, so this is the information that you'll need for today. So the first thing you're going to have to write down is that atoms and molecules, which we'll talk about later, they like to be neutral. Okay, what that means is they want to have no charge. Okay, that means that they don't like to be positive, so they dislike being positive, and they also dislike being negative. Okay, they want to naturally be neutral. They want to balance out. Okay, they don't want to be positive and they don't want to be negative. Okay, so what positive and negative charges like to do is they like to find each other and they want to balance each other out. They want to balance each other out so that there's zero charge. Okay, another word for zero charge is neutral. Okay, so atoms and molecules, they like to be neutral. So what they'll do is they'll react or interact, or they'll combine together in order to form a neutral particle with zero charge. Okay, so the key rule to remember is this right here. We're going to fill in the blank. So opposites attract, okay, which means like come together, and like charges, they repel, which means they push each other apart. Okay, so what does this mean? What does it look like? So opposites attract. So positive and negatives are opposite charges. So if you have a positive charge and a negative charge, what's going to happen? They're going to attract. They're going to get closer together. They're going to get closer together because opposites attract. And like charges repel. So the same charges, positive and positive, what are they going to do? They're going to push each other away from each other. And the same thing with negatives. The negatives will also push each other away. Okay, so if there's a positive next to a positive, it's going to push each other away. And if there's a negative next to a negative, they'll push each other away as well, while opposite charges will attract. Okay, and they do this in order to balance each other out, right? Because think about it this way. If I want to become neutral, if I want to get closer to zero, okay, if I have a positive, like let's say positive 2, and I have a negative 2, if I get close together, plus 2 minus 2, it's going to get to 0. But let's say I have a plus 2 and a plus 2. If they come together, what are they going to form? They're going to form a plus 4. Now the atoms, they're further away from 0. They're further away from neutral. So that doesn't make sense. They don't want to become further away from neutral. So that's why they push each other away. They want to get closer to 0. And that's why the positives and the negatives, the opposites, attract one another. And this is just another way of saying it. Ions with opposite charges will react together to neutralize one another. Okay, they want to get closer to zero charge. Okay? All right, so that's all the background information you'll need for today. And after this, we're just going to do some practice problems that you'll see on your assignment, and that'll be it. Okay, so we have a couple examples here, and let's just go through them together. So let me pull out the period. Actually, we don't even need the periodic table right now. Okay. All right, so we have two different ions. We have Li plus and we have H plus. Okay, so the question it's asking is how would they react together? So if I have an Li plus and an H plus, how are they going to react? So let's just think back to our notes. What did we say about ions? We said that opposites attract, and we said that same charges repel. Okay, so we just need to look at the charges on these ions and figure out, are they opposites or are they the sames? Okay, it looks like Li is positive, hydrogen is positive. So which one of these rules are they going to follow? I'll give you a second to think about that. Okay, obviously, since they're the same, they're going to repel. They're going to push each other away from one another. And so the answer here would be they just repel. Okay, because they're both positive. Okay, same charges repel. All right, let's go to number 2. This one you'll have to think a little bit more, but we're looking at how Al3+, aluminum 3+, reacts with neon. So we have Al3+ and we have neon. All right, so let's look at the charges. We see that Al is positive, right? Positive 3. But look at neon. Is there a charge here? There's no charge, right? If there's no charge, that means that neon is already neutral. This guy is neutral already. But aluminum is positive. Okay, so we have one positive and one neutral. Okay, and if you notice that in our rules, we don't have anything about already neutral atoms, right? We have opposites, but we know that opposites are positives and negatives. And we have sames, which is positive, positive, or negative, negative. But we don't have anything about neutral atoms. Okay, so what do we do here? Since neon is already neutral, neon is already happy. It doesn't really care. It's already neutral. It doesn't need to balance anything out. So what's going to happen is there's going to be no reaction. Okay, neon isn't going to want to do anything with aluminum because neon is already neutral. It's already happy. It doesn't need to interact with aluminum. Aluminum would only mess things up. It's positive, but neon is neutral. So here, we would have no reaction. Okay, so that's what happens when we have a positive and a neutral. And here in this first example, we had a positive and we had a positive, and we said that they repel. Okay. All right, last example for now. We have Ca2 plus and S2 minus. Let's look at the charges. Calcium is going to be positive, right, because it's positive 2. And we have sulfur, which is 2 minus, which means that it's negative. So here, let's look at our rules. Opposites attract, same repels. Are they opposites or are they the same? Okay, they're obviously opposites, positive and negative. So what they're going to do is they're going to like each other and they're going to attract one another. Okay, so that's basically the 3 main examples that you'll see. We'll have things that repel each other, things with no reaction, and things that attract. And you can tell that just by looking at the charges, or in this case, the lack of a charge. Alright, so hopefully this is pretty easy so far, but it is going to get just a little bit more complicated. So let's move on to the last couple set of examples. Okay, last 3. So let's start with number 4. Okay, so number 4, it's asking us how would Mg2 plus react with Cl minus? And then there's another question here. So we have the first part of the question and we have the second part of the question. Let's do the first part before we do the second part. So the first part, how would Mg2 plus react with Cl minus? If you notice, Mg2 plus is positive and Cl is minus. So are they going to attract, repel, or no reaction? Okay, should be pretty easy. Since it's positive and negative, they're going to attract. And the reason why is because we have Mg2 plus, which is positive, and we have Cl minus, which is negative. So they're going to want to get closer together. They're going to attract. So part one of the question, they're going to attract. Okay, but if you guys remember, we said that molecules and atoms, they want to neutralize each other. They want to get to a zero charge. But if you notice here, let's say that Mg and Cl got close together. Let's calculate the charge that they're going to form when they stick together. So we have 2 plus and we have a minus. We know that just a minus means minus 1. So if we have a positive 2 and a negative 1 and they come together, what's the charge going to be? It's going to be positive 1. Now, is positive 1 going to make the atoms happy? No, right? Because it's not 0. It's still positive. So this isn't good because the atoms are still unhappy. They want to get to neutral. They want to be neutral, which means they want to be 0. They want to zero out their charges. So the second part of the question is asking us, how many of each ion is needed to neutralize the charges? Okay, so here we add Mg2 plus. We said adding a Cl minus is going to make it positive 1. So which one are we going to need to add more of? Should we add more Mg or should we add more Cl? Okay, should be pretty easy. We know that we are going to add another Cl because the Cl is going to attract with the Mg, and what's going to happen? There is positive 2 and there's also negative 1, negative 1. That means that these two together are going to get negative 2. There's going to be a net negative 2 charge, which means they'll balance out. And so how many Mgs are we going to need? We're going to need 1 Mg2 plus, and we're also going to need 2 Cl minus. Okay, so let me draw it another way just to help you guys visualize it a little bit better if that was a little bit challenging for you. Okay, like I said, Mg is positive 2, right? 2 plus. Okay, so you can just think of it as having 2 positive charges. Cl has 1 negative charge. It's negative 1. So in order to cancel this out, you're going to need another one. You're going to need 2 Cl's, right? Because here the net charge is 2, positive 2. But on this side, you have negative 1 and negative 1, which is negative 2. And if you put these together, it's going to be 0. Okay, so the second part of the question, you're going to need 1 Mg2 plus and 2 Cl minuses. Alright, so let's do 2 more examples together and then we'll be all done. If you guys think you could solve this out on your own, go ahead and do so. But I'll leave both problems up on the screen so that you can pause it and finish them both up if you want. But if you're still having trouble or you're a little bit confused, I'll go over both of them with you guys right now. Okay? Okay, so number 5, it's asking us, how would Na plus react with O2 minus? So the first question is, how would they react? The second question is, how many of each do we need? So let's answer both parts. The first part of the question, Na plus and O2 minus. This one should be pretty easy. Looks like it's positive and looks like it's negative. So they are going to attract. Okay, positives and negatives will attract. Easy peasy. Alright, the second part is the one we need to figure out how many of each ion we need. So how many Na pluses do I need? How many O2 minuses do I need? Okay, so I'm just going to write them out right here. Na plus, O2 minus. Now first let's just kind of figure out which one has more electrical energy. Does Na have more or O? Okay, since O's number is bigger, it's negative 2, right? That means that this has more electrical energy. It's going to push it more negative. So since O has negative 2, But here, Na just has positive 1. Which one should we add in order to balance out the charges? Okay, obviously we're going to add an Na plus because 1 plus 1 will give you positive 2, which will balance out the negative 2, which will give you 0. So how many NAs do you need to balance out an O? You're going to need 2 NAs and 1 O2 minus. Okay, so again, all you need to do is count the charges and just make sure that the positives and the negatives balance each other out. All right, let's try the last example and we'll be all done. So we're going to answer both parts of the question. So for the first part is Fe3, how is Fe3 plus going to react with O2 minus? Okay, one's positive, one's negative, so easy peasy. This one is going to attract. All right, second part though, how many of each do we need? So let's just kind of take inventory. We have Fe3 plus and we have O2 minus. Okay, so let's think about this. Which one has more electrical energy, Fe3 plus or O2 minus? Which number is bigger? Okay, obviously Fe3 plus is a bigger number, right? There's going to be a positive 3 for the positive energy, but there's only going to be negative 2. So when you put them together, they're not going to balance. Okay, what that means is we need to add another negative charge. Okay, but we have a problem now because negative 2 and negative 2, what does that make? It's not negative 2 anymore. It's negative 4. Okay, so are they going to balance each other out? No, they're not balanced, right? Now there's more negative. So what that means is we're going to have to add another positive. So we're going to add another Fe3 plus. Okay, so we count that up. 3 plus 3 is going to give us 6, positive 6. But oh no, there's another problem again. Now it's positive 6 and now it's negative 4. So it's 2 positive again. So what we're going to have to do is we're going to have to add a negative, another O, that's negative. So we have negative 2, negative 4, negative 6, and now we are finally balanced out together. Okay, positive 6, negative 6, and they can balance to 0. Okay, so how many Fe3 pluses do I need? I need 2 Fe3 plus. How many O2 minuses do I need? I need 3 O2 minuses. Okay, so the key thing to remember is you just need to keep adding positives and negatives in order to balance each other out. I do want to note you cannot change the ions that are given to you, okay? So you can't add like a O negative. You can't do that just to balance it out easier. It has to be the charge that I give you. So you can't do like Fe plus, like Fe plus 2, just to balance it out. That's not going to work. You have to use the ions that are given to you in the problem. So don't get too creative. Stick with the ions that you're given and try to use those to balance each other out. All right, so hopefully that helped you guys. I'm on the Zoom call right now. If you guys have any questions, let me know if you guys have any questions, and I'll help you guys out. Good luck, guys.